Well, someone has rightly said, time is precious, do not waste it. With this, we start up today's topic, that is clocks and calendars. We will learn about different concepts of clocks and how to solve the questions based upon it. First of all, we will study how to find the speed of different hands of a clock. Since the hour hand is taking one round, that is 360 degrees, it is moving in 12 hours. So the speed of the hour hand will be 360 degrees over 60 times 12. On solving, we get half degree per minute. Since the minute hand will complete one round, that is 360 degrees in 1 hour, so the speed of the minute hand will be 360 degrees divided by 60 minutes, that is equals to 1 hour. And on solving this, we get 6 degrees per minute. So that means a minute hand will move 6 degrees in 1 minute. Since they are moving in the same direction, so the relative speed of both the hands with respect to each other will be simply equals to 6 degrees minus half degrees. That gives us 11 by 2 degrees per second. Now let's look at after how many minutes will both the hands of a clock coincide with each other. Now we all know that the time taken by the minute hand to overtake our hand is simply given as distance over the relative speed. Now the distance we all know is 360 degrees, while the relative speed is 11 over 2 degrees. Now on solving this, we simply get 65 511 minutes. So in other words, that both the hands will coincide after every 65 511 or 720 over 11 minutes. Remember, in 12 hours the hand will coincide 11 times. The next thing which is very important is the angle between the two hands. The angle between the two hands is simply given by formula absolute of 30 times h minus 11 over 2 m degrees, where h simply means the hour reading and m simply means the minute reading. So do remember this special formula. Now here is an example based upon the previous formula. Calculate the angle between the two hands of a clock when the clock shows 5:25 p.m. Now over here we simply know that our hand is basically 5 and m is basically 25. So now we can apply the following direct formula to find the angle between the hands. That is 30 times h minus 11 over 2 m degrees. So the required angle will be 30 times 5 minus 11 over 2 times 25. So on solving this, we simply reach 12.5 degrees. So our answer will be third, that is 12.5 degrees. Now this similar question can also be done in an alternative way. Since over here the time is 5:25 p.m. the minute hand will be at 5 and the angle between them will be same as the distance covered in degrees by the hour hand in 25 minutes. So the required angle will be simply equals to the distance of the hour hand, and that is simply equals to the speed of the hour hand multiplied by the time taken by the hour hand. So speed is simply half degree and time is simply 25 minutes. And on solving this, we simply get 12.5 degrees. Have a look at this question. At what time between 4 and 5 o'clock are the hands of the clock together? Now there are different ways to do this question. Let's look at the very first way. At 4 o'clock, the hour hand is basically at 4 and the minute hand is basically at 12. It means that there are 20 minute spaces apart. To be together, the minute hand must gain 20 minutes over the hour hand. Now we know that 55 minutes are gained in 60 minutes. So 20 minutes will be gained in 60 over 55 times with 20. That makes 240 over 11, or you can say 21 9 11 minutes. Therefore, the hands will be together at 21, 9, 11 minutes. There is another way to do this question. We will simply use the formula 2 over 11 times with h times with 30 degrees plus minus theta. Now we know that theta over here is simply equals to 0 because the hands of the clocks are together and h is equals to 4. Now by plugging in, we simply get our answer as 21, 9, 11 minutes. Now let's see, when is the clock too fast and too slow? If a watch indicates 9:20 when the correct time is 9:10, it is said to be 10 minutes too fast. And if it indicates 9 when the correct time is 9:10, it is said to be 10 minutes too slow. For example, a clock loses 2 minutes for every hour. If this clock is set right time at 1 p.m., find the right time when this clock shows 7:17 p.m. Along with this, the options are given as 7 p.m., 7:04 p.m., 7:30 p.m., 7:43 p.m. or 7:47 p.m. Now you can try this question on your own. Now let's understand what is overall gain or loss. After every 65, 5, 11 minutes or 720 over 11 minutes, we all know that the two hands will coincide. If the hands of a clock coincide every x minutes, then the gain or loss is given by 65, 5, 11 minus x over x. Now if this is positive, then there will be a gain. If it is negative, then there will be a loss. Now let's look at this question. In a clock, the hands will coincide once in every 64 minutes. How much time it gains in 22 hours? Now we all know that the gain per minute is simply equals to 720 over 11 minus x over x. Now over here, x represents the time after which the hands coincide. Now in this question, x is basically equals to 64 minutes. So the gain in 22 hours will be now equals to 720 over 11 minus 64 over 64 times this by 22 times with 60. So this turns out to be 30 on solving it. So our answer will be 30 minutes. Now let's look at this example which came in CAT 1996. In a watch, the minute hand crosses the hour hand for the third time exactly after 3 hours, 18 minutes and 15 seconds of a watch time. What is the time gained or lost by this watch in one day? Now, in a correctly running watch, the crossing of hands should take place after every 720 over 11, or you can say 65 5 over 11 minutes. Now in this watch, it takes place after 3 hours 18 minutes 15 seconds over 3. So that gives us 1 hour 6 minutes and 5 seconds, or you can say 66 5 over 60 minutes of the watch time. Now this watch takes a longer time to accomplish the task as compared to a correctly running watch. So that means the watch loses time. Now how much time it lost? It is going to be 66 5 over 60 minus 65 5 over 11. That makes 83 over 132 minutes in 65 5 over 11 minutes of correct time. So now in one day, that is 24 times 60 minutes of the correct time, it will lose 83 over 6 minutes, which is equals to 13 minutes and 50 seconds. Hence our correct answer will be second.